Hey guys, this is the third section and also the last section of inequalities. So after this, we'll move on to the next unit, which is trig unit, the big unit. Anyway, so this is on section 9.3, quadratic inequalities in two variables. What is that? So the graph of a quadratic inequality is similar to the graph of a linear inequality. So this is definitely good news. So that means whatever you learned 2 lessons ago, the first lesson on inequalities in this outcome, you can apply, if not all of them, at least most of them, to what we are learning today. Okay? Next. So in this case, if you recall that lesson, or if you don't remember that, you might want to go back and to the lesson, either look at a PDF file or watch the videos again. Anyway, as we go over the notes, I'll briefly brush up your memory, remind you guys what you learned from the first lesson on inequalities. Okay, so there is a boundary line and a shaded solution area. Okay, so I hope your memory is back as we go over this. So the difference is that the boundary line is a parabola. So literally it's the same thing, except for the first lesson on inequality, we are dealing with inequalities for a linear function, straight line. Here we are doing the same thing, except we are dealing with a parabola instead. Okay, so we call that if we have less than or equal to or greater than or equal to, we use a solid line. Why do we use a solid line? Because we have the equal component there, so it is inclusive. If you recall the lesson that we finished yesterday or the last lesson, when we have the equal component, we are including that number, whatever that number is. Okay, and then if we have less than or greater than, then the boundary line is a dotted one. So we do not include whatever value we are referring to here or here. Alright? And then if we have less than or equal to or less than, then shade the area below. So less, below. If it is greater than or equal to or greater than, so that means greater, we do above. Alright? So as we work our examples, your memory will be back. So let's look at the first question. Graph this. Graph y less than -2 times x minus 3 squared plus 1. So basically we are going to draw the boundary line, shade the region. Now if you remember the technique that I passed on to you, then let's do this. If you are annoyed by the inequality sign, less than, greater than, less than, equal to, greater than, equal to, you can do this first, okay, for now at least. So let's graph this. The nice thing about your graphing calculator is it is smart enough that you don't have to manipulate the equation that I just showed you. So if you look at this here, basically you can just plot like this without having to doing the FOIL and then distribute that, right? So -2 open bracket x minus 3 close bracket square plus 1, and then graph. Alright, so math 10C stuff. Let's quickly look at several key points. Second trace, in this case, if you look at the graph, we have a max. So again, we're going to do the same kind of stuff. Look at the vertex, find the x-intercept, so number 4 for the max. So left bound, and then move the cursor to find the right bound. Enter, enter again. So that means my max, the vertex is 3 and 1. So 1, 2, 3, and 1 right here. Vertex is 3 and 1. Alright? And let's find the x-intercept. Second trace, number 2. So left bound, right bound, enter. Well, if you want, you can plot this 3.71, 3.7 and 0. 1, 2, 3 and 4, 3.7, 3.71 is something somewhere around there. That's one way. I think I did something like that on the last lesson, and if you want, you can do it this way. Second graph, find some nicer point. So if you look at this, 2, -1, 3 and 1. Okay, so 2, -1, 3 and 1. Two, -1 right there. And then the other one is 3 and 1. We did that. What else? 4 and -1 right here. 4, -1. So 1, 2, 3, 4, 4 and -1 right there. So even though we are not using the x-intercept, it's okay. Something like that. And then this, this, you can call it f of x, g of x, whatever, or simply write this down. Y, in this case, for this is the graph, equals to -2 times x minus 3 squared plus 1 right here. That's the one we're looking at. Alright, next, let's answer this. Graph this, and then now let's take this out. Let's find out the region that satisfies the condition. Y is less than this. Less than, that means below. Anything here is greater than, above. Anything here below the graph, under the graph, is less than and below. So therefore, in this case, we are going to shade this region here. All the way to infinity, like this. Alright? Now, one more thing we need to look at is, because this is less than, there's no equal sign. So what do we need? Not a solid line, instead a dotted line. When you graph this, when you sketch the graph, you can start off with a dotted line, then you don't have to come back and change anything. And here, well, it's just a little bit of extra work. You can take an eraser and make a dotted line like this. So here we go. Right? So dotted line, because, well, maybe I should write down here. So because of this sign, we shade the below region. So below, and also because we don't have the equal component, so therefore we use the dotted line. Next, is 2 and negative 4 a solution? Algebraically determine that. So let's cheat a little bit, or I shouldn't say cheat all the time. So let's be smart. Let's look at this graphically. 2 and negative 4. One, two, 1, 2, 3, 4. So 2 and negative 4. If you want, call that point P. Doesn't matter what you call that. 2 and negative 4. Is that a solution? If you look at this graphically, definitely this point 2 and negative 4 is in the shaded region or the highlighted region. So definitely it is the answer, or it is a solution. So let's do this graphically. Sorry, I mean algebraically. So what do we need to do? Well, that's easy. Plug that in here. That's x and that's y. So plug in 2 for x and negative 4 for y. I'm too lazy to write that thing. So anyway, so y is 4, negative 4, less than, and then just like what we did before, verifying something, plug in numbers and then see if the left hand side is equal to the right hand side. So negative 2, and then my x is 2 minus 3 square plus 1, and then left hand side is still negative 4, right hand side negative 2 times 2 minus 3 gives you negative 1, and then you square plus 1. After that, negative 4 on the left, and then here negative 1 square that means negative 1 times negative 1, that gives you 1. 1 times negative 2 gives you negative 2, and then plus 1, and then negative 2 plus 1 gives you negative 1. Is negative 4 less than negative 1? Or you can say that is negative 1 greater than negative 4? Of course, that's correct. So what does that mean? That means it is a solution. So say something like, oh, 2 point, I'll just do it here. So that therefore 2, negative 4 is a solution, period. Just like that. Alright, so question 2. You might want to pause for a few minutes, quickly try this out. Okay, so let's do this. Again, just to let you guys know that some students show me that you can actually graph this, but I don't know how to do that. Just that you know, you might want to check out your calculator menu to see how you can actually graph something like this. Anyway, so if you are annoyed by the inequality sign, then you can do it for now. So graph this, y equals to x squared minus 2x minus 3. So y equals to x squared minus 2x minus 3 and graph. So this one, if you want, you can eyeball that, but again, if it is for assignment, test, final exam, better make sure that, because even though it looks quite obvious that this is 1, 2, 3, 3 and 0, this is negative 1 and 0, but it may be 3.01 or 2.99, so don't take the risk. Okay, so let's figure those out. So 3 and 0, negative 1 and 0. Three and 0 right there. 3 and 0, and then negative 1 and 0 right there. So that's negative 1 and 0. Of course, we have one more thing to find, which is the vertex, or to be specific, our minimum, second trace, number 3, left bound, yes, right bound, yes, and then enter again. That gives you, well, that's literally 1, so 1 and negative 4. So 1 and negative 1, 2, 3, 4 right there. Vertex is 1 and negative 4. So now you can graph this. Maybe I should make this longer because I want to so that the result would be more obvious. So this one is y equals to x squared minus 2x minus 3. Alright, so now let's erase this, because the one we're looking at is not a normal equation, it is an inequality equation. So y is greater than or equal to a few seconds. What does that mean? Okay, so greater than means you shade the above region above, and because we have the equal component, so therefore that means we use a solid line. So this time we don't have to like erase out part of that to make a dotted line, dotted graph. So let's shade the region. It is above, so anything here is below. Look at this, below, below. Here it's above, this is above, so you are going to shade this region all the way to infinity. Next, choose a test point from the solution area and see if it satisfies the inequality. So there's so many points you can pick, but again, pick something easy for you. If I were you, when I look at this graph here, the shaded region, the highlighted region, well, this one is a good one, 0, 0. So let me pick that. You can pick any other points, it would work out the same, except the numbers are different. So let's pick a point. This one is 0, 0. And for your test, exam, whatever, if you're not sure whether you did something right, you might want to do a test point. That's why for second question in a row, we pick a test point. Okay, so if you shade it wrong, the answer would tell you that. So in this case, we shaded the region above or inside, so our answer should work. So now let's do this. So well, I don't want to scroll up and down all the time, so the answer, the answer for part B is here. So for part B, use point 0, 0, and that's x and that's y. Okay, so now let's put that here. Y is 0 greater than or equal to 0 square minus 2 times 0 minus 3, left hand side, 0 greater than or equal to, this gives you 0 minus, this gives you 0 minus 3, left hand side 0 again, greater than or equal to, right hand side 0 minus 0 gives you 0, 0 minus 3 gives you negative 3. So if you look at this, 0 is of course greater than or equal to negative 3. And in other words, you can also say that negative 3 is less than or equal to 0. So this is correct. If this is not the case, that means you shaded it wrong. You shaded the region wrong. Okay? Okay, next one. If you think your graphing calculator, if you think you don't have to pay attention and because your graphing calculator can do everything for you, think again. Have a look at this question. Write the inequality shown by this graph in vertex form. Okay, so obviously your graphing calculator can give you the answer directly. can only tell your graphing calculator what to do. So in case if you have a bad memory that you don't remember what's the vortex form, you should, I hope, remember that, because this course is cumulative, so you will need some of the prior knowledge anyway. So the standard form for quadratic equation, and this is the vortex form. I hope this reminds you something. Alright, now let's write this down first. So from the formula sheet, we figured out that the vortex form is y equals to a times x minus p squared plus q. You don't have to memorize this, but you need to know what's a, p, q, and stuff like that. Alright, so next, plug the numbers in. What do we plug in? If you look at this, this is my vortex right here. What's my vortex? Vortex is 0 and 3. So that means my p is 0, my q is 3. So plug that in. So y is a times, well, in this case, p is 0. I'll skip a step here. You can write down x minus 0 squared, which gives you x, and then x squared gives you x squared. Alright, so let me just skip a step. Well, you know what? Maybe on a second thought, I'll still write down. So x minus 0 squared, because I don't want to confuse any of you, and then plus 3. Okay, p and q. So we can simplify this a bit more. A times x squared plus 3. Now, if you recall this, hope you still remember that we did something like that in the quadratic unit. So how do we figure out a? Because this is the only thing that we don't know. Don't pick the same point here. You can pick any other point but not same point, because it would not give you anything. So you can either pick this point, which is 2 and 7, or this point, negative 2 and 7. I don't want to deal with negative numbers, so I'll just pick this point, 2 and 7. So use point 2 and 7. And what do we do with this point? Plug in 2 for x, 7 for y. Now if you plug the numbers here, so that gives you 7 equals to a times x, which is 2, and then square plus 3. Now you can work out the rest. 7 equals to a, well, 2 squared gives you 4, so let's write this, write 4a instead of a4, plus 3, and then we can quickly do the algebra here. Minus 3 on each side, that gives you 4 equals to 4a, and then divide 4 for each side, so that means a is 1. Now once you know a is 1, what do? Plug in 1 for a back here. So that means my general equation is y equals to 1, you can leave that out, x squared plus 3. Okay, and we are done. No, you screw up if you stop here. Why? Look at this. What's the keyword here? Inequality. Do we have an inequality sign here? Not yet. So look at this graph. What does that tell you? Did we shade above or below? Below means less than or equal to or less than. Is it less than or equal to or less than? Look at that, the dotted line. So that means not then. So that means it must be less than. Okay, so just rewrite that. So y is less than x squared plus 3. Done. Okay, last question. Have a quick look. Alright, so for part A, sketch a graph representing the microphone. So the question talks about a parabolic reflector, so parabola. So it would look like this. I don't care how, whether you draw a wide one or a narrow one like this. Okay, if I were you, I would not draw it upside down because you're talking about -1, so you don't want to deal with that. Next one, next part. Find the inequalities. Find the inequality representing the region that can be covered by the microphone. Ensure that your inequality. Oh, inequality. So that means we have the less than, greater than, maybe less than or equal to, greater than, equal to, but at least definitely not an equal sign. Alright, so if you look at this, in order to do this, figure out the equation, we definitely need to do more than what we just sketched here. Alright, so if you look at the question, you may still remember that we did something like this for a bridge in the quadratic unit. That there are two ways we can label this, because we need more labeling, more explicit, more detailed labeling, so that we can set up our own equation or our own inequality. So there are two options here. You may remember that. If not, go back to the quadratic unit. So you may set our vertex either here. So I mean, you may set your origin, the point 0, 0 as your vertex, or you may set the left-hand side as your vertex. Of course, you can also set this to be your origin 0, 0, but well, in this case, your graph would be on the negative side of the x-axis. So we'll just sketch the two scenarios. Either have the origin here, so that's one way, 0, 0. Then let's label a few more points, because if you look at this, the refractor has a width of 50 centimeters. So that means it is 50 centimeters wide and a maximum depth of 15 centimeters. So that means this is 15 centimeters deep. Alright, so now let's label a few more points. If this is 0, 0, so this divide this into 25 and 25. And if this, in terms of the horizontal value, and if you look at the height, if this is 0, that means this is 15. So that means this point, it is 25 and 15. 25 and 15. If you look at this one here, positive 25, so that means this is negative 25, and the height is still from 0 here, go up 15, so negative 25 and 15. Negative 25 and 15. That's one setup. Remember the bridge question? I know you will say we have never done that, whatever. So we can, I mean, if it is an assignment, test, final exam, whatever, you can just set it up like this and then proceed. You don't have to draw me both ways, but I just want to show some of you both ways, so that if this way doesn't make sense, at least you can try it this way. Okay, so in this case, we are going to set this part to be my origin. Oops, wrong color. This is my 0, 0, the origin. Again, this is 50 centimeters wide, so that means that would be 50 and 0. So this point here is 50 and 0. Because to some of you, one way would make more sense than the other. For others, both way makes total sense, and for a few others, I hope not, none of these make sense at all. Anyway, so we can label the last point we want to locate, to identify, is this vertex here. So if the whole width is 50, so this is halfway through, so this is 25. From the origin, and then if this is 0, going down here by 15 units, so 25, and negative 15. So let's label this. So if you want, you can call this option 1, approach 1, I don't care, but let's just keep track of that. This one is option 2, method 2, second method, whatever. Okay, now write the inequalities. I'm going to work out the questions in using both sketches. Use this one, work everything out. Use this one, work everything out as a video. And one last time, if it's an assignment, test, quiz, whatever, you don't have to draw me every single way and then work out every single solutions. Nope. Okay, so if you look at this, this is somewhat similar to the last question that we did. Okay, so we are going to take advantage of the vortex form of a quadratic equation. So that means we are going to, this one here, in case if you don't remember the vortex form, we just used this formula for the last question. Y equals to a times x minus p squared plus q. So option 1, y equals to a times x minus p squared plus q. Okay, so in this case, for my vortex, it is 0, 0. So that means my p is 0, q is 0. So plug those in. Y equals to a times x minus 0 squared plus 0. So we can simplify this a bit, of course. Y equals to a times x squared plus 0. So like this. Okay, and then of course, again, just like the last question or like what we did before in the quadratic unit, we just pick a point. Doesn't matter, you can pick this point, x and y, x and y. Okay, so pick, let's use a positive one. There's nothing wrong if you use this one. As I told you guys before, stay away from negative number or negative sign. So 25 and 15. So pick 25 and 15. So that means this is my x and this is my y. So plug those in. So y is 15 equals to a, that's what we're trying to find. X is 25 square. And then work out the math, of course. So 25 squared gives you 625. Well, you may notice that I flipped the order because it's kind of weird if I write down a 625. Anyway, so divide both sides by 625, and in this case you will end up with a decimal, not a perfect one, so we want to leave that as a fraction so that we have an exact value. So 15 over 625. And of course, you can simplify this. So that means a is 3 over 125. Now we know a, we can plug in a, which is 3 over 125 here. So y equals to ax squared, y equals to a, which is 3 over 125 x squared. And we did ourselves a big favor by highlighting this so that we know we are looking for inequality. So if you stop here, I'll give you an E minus. Okay, so in this case, have a look at this graph. Which region do we shade? Okay, so I hope you all agree that I should be shading this region like this. Describe the region that Rene can cover with his microphone if the reflector, so cover up this, so therefore it will be here, this region. This region is above the graph, this is below, so above means greater than or greater than or equal to, and in this case if you use common sense, I cannot have a pitted microphone reflector, so this must be a solid line, so therefore I have greater than or equal to. So y is greater than or equal to 3 times 1 over 25 x cubed. Because if you try to do this, make a dotted line, it looks kind of weird. Like if you have any microphone refractor or something, some cover, then you know what I mean. Okay, and we also have to talk about this. Include an appropriate domain. So in this case, the domain, the horizontal stuff, the x-axis is somewhere between 25 and negative 25. So in this case, your x is somewhere between 25 and negative 25 and inclusive, because you can have a point here, right on here. So inclusive, including 25 and negative 25. So we are actually done for this question, but for those of you who prefer to use this graph to set up question, let's finish this. So same thing here. Alright, so I'm going to go a little bit fast. Y equals to 8 times x minus p squared plus q. So if you look at this, in this case, my vertex is 25 and negative 15. So p and q. So y equals to 8 times x minus 25 squared, and then remember you flip the sign, positive, flip that, negative, this, the q, the y stuff, you leave that, so minus 15. And of course, we're going to finish this question the same way, find a point, plug that in for x and y, and then solve for a. So if you look at this, there's nothing wrong if you pick 50 and 0, but I'll definitely pick 0 because that's easier. So pick the point 0, 0. Okay. Pick the point 0, 0. So in this case, my x is 0, my y is 0. So just plug x and y here. 0 is 8 times 0 minus 25 squared minus 15. So keep doing to simplify this. So 8 times negative 25 squared minus 15. So you can move the 15 to the left hand side, so that gives you 15. And then if you look at this, negative 25 squared gives you 625 times a gives you 625a, and then divide both sides by 625, so a equals to, you don't get a perfect decimal, so leave that as a fraction. Okay, so 15 over 625, and if you look at this, you can definitely simplify this by dividing top and bottom by 5, so that gives you a equals to 3 over 125. Okay, then same thing, plug in a here. Okay, so y is equal to a, which is 3 over 125. What else? X minus 25 square. X minus 25 square, and then minus 15. Minus 15. Okay, and then one last thing. The domain. In this case, it goes from 0 to 50. So I don't have enough space, so I'll just write down here. X is somewhere between 50 and 0, less than 50, greater than 0. And again, it is inclusive. It could be 50 right here, it could be right here at 0. So we keep that equal because we have, just like what we did before, the refractor this is the region of the refractor that can receive the signal, and then our refractor, of course, is or should be a solid line. So And of course, we need to change that to the inequality sign. So same thing, this is above the graph. So y is greater than or equal to 3 over 125 times x minus 25 squared minus 15. You will probably say, Cheng, the two equations look different. Well, because the way we set them up was different. But if you remember the bridge question, each way has its own advantage. If you use some other numbers to plug that in and solve something, both equations or both inequalities would give you the same answer. Okay, so if there are no other questions, well, sorry, I can't see whether you have questions or not, but we can pick that up in our tutorial or virtual classroom next time. So these are the questions you can try. Enjoy.